Hello everyone, welcome to this video. In this video, we are going to solve question from December 2019 consisting of 4.75 marks. The question is, the minimum value of the functional I of y, which is given to be integration from 0 to pi y dash square dx, subject to the given condition that this integral is equal to 1 and the boundary conditions are given to be 0 at the point 0 and pi. So we need to tell the minimum value is equal to which of these, right? So we know this is a variational problem. With subsidiary conditions. Right? So how do we solve such kind of problem? We construct another functional, say j, which is equal to, if this is f and this is g, right? Then we can write this as f plus lambda times g, right? So which is equal to y dash square plus lambda times y square. And the Euler-Lagrange equation corresponding would be the value of jy minus ddx of jy dash, or we can say that it would be f of y minus ddx of fy dash plus lambda times gy minus ddx of gy dash. So let's solve this part. What is f? F is y dash square. So what would be fy? Fy would be 0 minus ddx of fy dash, that would be 2y dash, right? Plus lambda times gy. What is g? G is y square, so it would be 2y minus ddx of gy dash, that would be 0, right? This is equal to 0. So let us solve this. It would give us minus 2y double dash plus 2 lambda y is equal to 0, or we can take 2 common out. So we would obtain y double dash minus lambda y is equal to 0. Now this kind of equation with lambda unknown is a second order Sturm-Liouville kind of problem, right? So depending on the values of lambda, we have different cases. So let us say case number 1. Case number 1 is we have lambda is equal to 0. If lambda is equal to 0, in that case, what our equation becomes? Y double dash is equal to 0. So solving this, we would obtain y is equal to c1x plus c2, right? Our boundary conditions are y at 0 is equal to 0. So this gives me c2 is equal to 0, and another condition is y at pi is equal to 0. So this gives me c1 is equal to 0. So overall, I'll have y is equal to 0 as the solution in this case, right? Let us see another case, which is the trivial solution, as you all know. So second case is, if I assume lambda to be a positive number, lambda is positive. So that means I can take lambda is equal to some n square, right? So in this case, our equation this becomes y double dash minus lambda minus n square y is equal to 0. So let us solve this, write the corresponding auxiliary equation, which is this. So I have d is equal to plus minus n. So this gives me y of x is equal to c1 e to the power nx plus c2 e to the power minus nx, right? So now let us use the given boundary conditions. We are given y at 0 is equal to 0. So this gives me 0 is equal to c1 e to the power 0 plus c2 e to the power 0. So ultimately I'll get c2 is equal to minus c1. So let me substitute this value back into this equation. So I'll have y is equal to c1 e to the power nx minus e to the power minus nx, right? So let me use another boundary condition, y at pi is equal to 0. So this gives me 0 is equal to c1 e to the power n pi minus e to the power minus n pi. So this gives me either c1 is 0 or e to the power n pi minus e to the power minus n pi is equal to 0. Now if c1 is 0, this means c2 is also 0. That means y is equal to 0, which is again the trivial case. And if this thing is 0, this means n is equal to 0, which again gives you y is equal to 0, which is the trivial case. So here also we don't obtain the non-trivial solution. So let us see third case, that is where lambda is negative number. If lambda is negative, so I can take lambda is equal to minus of n square, right? So in that case, my equation would become y double dash plus n square y is equal to 0, right? So this gives me d square plus n square is equal to 0. So solving this, I have d is equal to plus minus iota n. So what is y? Y of x would be c1 cos of nx plus c2 sine of nx. So let us solve this using the boundary conditions. We are given y at 0 is equal to 0. So 0 is equal to c1 is equal to 0. And so our y becomes y is equal to c2 sine nx, right? So now let us use the second condition, that y at pi is equal to 0. So this gives me 0 is equal to c2 sine n pi. Now we have two options from here. Either c2 is equal to 0, this would lead to y is equal to 0, again the trivial solution. So we'll see the other option, that sine of, so we don't require this. So we'll take sine of n pi is equal to 0. And at which point sine is 0? So it is 0 at the multiple of k pi, where k is some integer, 1, 2, 3 and so on. Positive integer or negative also, it could be negative also, right? Plus minus 1, plus minus 2 and so on. So in that case, what is n? N is equal to k. If n is equal to k, our solution y would be c2 sine kx, where what is this k? K is equal to plus minus 1, plus minus 2 and so on, right? So this is our y, the extremal. But let us look at the question. In our question, what was asked? It was asked that find the minimum value of this functional. So let us try to solve this functional, right? If I substitute the y in my functional, I would have, moreover from here, we need to find the value of c2, which would be determined using this given subsidiary condition. We haven't used this yet, right? So let us use this first to determine what c2 is. So the condition was 0 to pi y square dx is equal to 1, right? So let me solve this. So I have integration from 0 to pi. What was y? Y was this. So we have c2 square sine square k of x dx is equal to 1, right? So c2 square I can take common. So I have integration from 0 to pi. Sine square kx, I can write this as 1 minus cos 2 kx divided by 2 into dx is equal to 1. So let me solve this. So I have c2 square, and integrating this I have x by 2 and minus sine 2kx divided by 4k, and limits of integration from 0 to pi. This is equal to 1. So solving this, I have c2 square, and the first term would be pi by 2, sine of pi would be 0, then 0, and then sine of 0 would be 0. So this is equal to 1. So I have C2 square is equal to 2 upon pi. So this gives me C2 is equal to root of 2 upon pi. If C2 is this, so what our y becomes? Our y becomes square root of 2 upon pi multiplied by sine of kx. This is our y, right? Now let us see what is the minimum value of I, the given functional. So I of y is given to be integration from 0 to pi y dash square dx, right? We have to find its minimum value. So let me put this value of y over here. So I have integration from 0 to pi, right? What would be the derivative of this? So this term being constant will come as it is, and the derivative of sine kx would be cos kx multiplied by k, right? So I have the square of this whole thing into dx. So let me solve this. What would I obtain? K square multiplied by 2 divided by pi, being constants come out of the integral sign. So integration from 0 to pi, then I am left with cos square kx dx, right? So let us solve this. Let us see what do we obtain. Again writing this as 1 plus cos 2kx divided by 2 into dx. Let us integrate this. So we have 2k square by pi as it is. So it is x by 2, and the integration of cos would be sine 2kx divided by 4k. Again the limits are from 0 to pi. So let us substitute the limits into the given function. So we would have pi by 2, sine of 2k pi would be 0, right? Then minus of 0 and minus of 0. So ultimately we'll have this as the value 2k square by pi into pi by 2. So this gives me k square, where what was our k? K was our plus minus 1, plus minus 2 and so on, right? So what we are doing? We are looking for the minimum value of I. So the values of I would be, if I put k is equal to plus minus 1, it would be 1. If I put k is equal to plus minus 2, it would be 4 and 9 and so on, right? And we are looking for the minimum value. So the minimum value is 1. So let us look at our options. So this gives me option B as the correct option, right? Thank you for watching the video. If you like the video, please share and subscribe to the channel. Thank you.